Okay, so good afternoon, everybody. Uh, Before I continue what I started last time, I just wanna link what I'm doing in this chapter with what I did in last chapter, in chapter 2. Okay. So in chapter 2, given a truth table like this one, you can write the function in sum of product and product of some format. Okay, and that's what I'm gonna test you today in the quiz. The way we did it is, if you want to make it in sum of product, so you have to select the ones here, and every one here is gonna contribute by one term. Is that okay? And this term has x, y, and z. It has the three variables. And we call them min terms. That's what I did in chapter 2. And I told you this function, the function we got is correct, but it's not simplified. That is why what I did in chapter 2, I used algebra manipulation to simplify it. Is that okay? So, okay, that's what I did in chapter 2. In chapter 3, I just want to show you the link. Where is the link? Okay. Here in this chapter, what I'm gonna do is, as you see here, given this truth table, so I'm gonna map this truth table into the key map, as you see here. Okay, so this one will be here, this one is here, this one is here, and so on. So everyone is gonna be here, every min term is here, and then this is the trick. And then if I take everyone individually, I'm gonna get the same formula I got in chapter 2, sum of product. I'm gonna get the same formula, and it's not simplified. That is why the interesting part is I can group these ones together. Okay, that means if I can group these two together, that means instead of having two terms, one term for this one and one term for this one, as we did in chapter 2, no, we can only have one term here. Okay, same thing if I can group 4, that means 4 min terms, because remember this equation here is min term, for example, min term 1 or min term 4 or min term 5 or min term 7. This is the function. That's what we did in chapter 2. What we're doing now is I can, for example, 1 and 5, I can combine 1 and 5 together and make only one term using the maps. Okay, and using maps is much easier than algebra manipulation. Is that okay? However, you have to be careful here. Okay, how I do these groups. Okay, I made it very clear last time. There are three requirements. Okay, or 3 rules. These 3 rules are correct in case of 3 variables, and it's the same thing for 4 variables. Number 1, if you put all ones you have here in groups, you are gonna get a correct function no matter what. The function is correct. Okay, if you can cover all ones here in groups, but it may not be the most simplified. To make it the most simplified, 2 things you have to do. That's what I said last time. Number 1, try to minimize the number of groups that can cover all these ones. You got what I'm saying? So if I do it in 2 groups or 4 groups, someone else did it in 2 groups, the 2 functions are correct, but the 2 groups is going to be more simplified. Okay? This is one thing. The other thing is, because every group is going to have one term in the function. Okay? One more thing, the bigger the group, it's going to be the better. Why the bigger the groups is the better? Simply because, as I told you last time, the bigger the groups, the term itself is going to be more simplified. It's going to have less number of variables, as I explained last time in much details. So last time I told you, if you take only one square, the term here is going to be has 3 variables, as you see here, and this is chapter 2. This is the main term in chapter 2, right? Exactly same thing like chapter 2. However, if you combine two together, look what's going to happen. Number one, I'm not going to get two terms. I'm going to get only one term, and this term has only two variables. Okay? Same thing, if I can do it if I can combine four together, make it one group. In this case, instead of having four terms in the equation, I'm going to have only one term. And this term has only one variable. Very, very interesting. Okay, and very easy comparing to algebra manipulation. However, you have to know how to make groups. You have to know how to do it. Okay? So as I said last time, groups can be only one variable. One square. It can be two squares or four squares. Nothing else. They can't be five. Okay. It can't be three or nothing else. It should be one, two, or four. Is that okay? And also that's why last time also I explained the idea of neighbors, how I can tell if these two squares are neighbor or not. So as you see here, every cell has three neighbors. So I can group neighbors together. That means, so as you see here in the two mini example here, these two, I can group them together. Yes, I can, because they are neighbors, okay? Even these two, this one here and this one, I can group them together because they are neighbors, as I said last time. Is that okay? So yes, neighbors, I can group neighbors together, okay? In case of four, if you have, for example, here, in case of four, I can take these four together as one group. I can take these four together as one group. Is that okay? You can take these two here and these two here as one group, okay? Because it's actually, you can see it like this is these two and these two are neighbors to each other, okay? But anyway, we're not going to do this. We're going to say this is one group, okay? Also, I can take, if you have here, yeah, I think I already mentioned it. Okay, so you can take this four here, you can take this four, or you can take four this way. Okay. Yeah. So three is not allowed. So all what you have to do is, as I explained last time, you have to be careful in making the groups. Okay. You need to cover all ones. You need to try to list the number of groups that can cover all of them. Also, a very interesting thing I told you last time, overlap between groups is allowed. Okay, as I said last time. For example, as you see here, okay, so this is one group and this is another group here. There is an overlap here. This is allowed. However, subset is not allowed. Subset. So for example, if I say this is a group and then I'm going to make another group here, it's not allowed. Actually, you don't need. That's why it's a redundancy, because you already covered. I already covered these two. So why I cover them again? I already covered by this one. That's why subset is going to make a redundant term in your equation. Okay. Anyway, and then you have too many examples here. I explained some of them. I will try to also continue, but I don't think I need to teach all of them. You have 14 of them. Okay, you have too many anyway. I think I stopped here. No, here, I guess. Anyway, so for example, I think what I want to do today, because listen, it's a little bit tricky. If you already has a solution, it's not, this is not the best way to learn this topic, okay? If you just look at the solution, yeah, it's easy, okay? But if you try to do it by yourself, it may be difficult, okay? That's why what I'm gonna do right now, I will try to, yeah, maybe I'm gonna copy this slide here, and then I'm gonna remove, this one's here. I'm gonna group this one. I'm gonna, like, instead of just working with the solution, this easy part, I'm gonna work on, for example, here, if I'm a student and I want to solve this one, okay, look how I can do it. Okay, the way I'm gonna do it, guys, is, for example, let's look at this one here. Let's look at this one. Okay, what options do you have for this one? I have two options. I can take it alone this way, or I can take these two together. In order to cover this one, I have two options. I can take this one alone, or I can, because these are neighbors, I can take them together. Which option is better? For sure to take these two together. So this is not a good idea to do this one. And this will be, do you have a better option? No, I don't. This is the best. I don't. Why? Because this one can be in a group of two. The next option, or the best, or a better option, is to make it group of four. But I can't, because I have it here. I can't. Got what I'm saying? So the best thing for this one is to make it in group of two. Okay, let's look at, for example, let's look at this one here, for example. So these two already covered. Okay, again, what is I have? What is the I can take it alone, or I can take with neighbor. So the best solution just to take it with neighbor this way. You got what I'm saying? So in this case, it's enough. I can make one group here, and I can make a second group here. Is that okay? Please don't make this as a third group. You don't need to do that. This one is already covered here, this one is already covered here. So this is gonna create another term that's redundant. You don't need it. You already covered all ones using two groups. So don't make this one already. I covered all of them in groups. You got what I'm saying? So what I'm explaining here, yes, you are gonna get a correct formula, but it's not the most. You have one redundant term, and if you do simplification, you will find this term, or it's redundance. Okay. So anyway, so the second thing I want to teach. So we already agree. This is the best option. I can have two here, and I can have two here. Is that okay? Look here, guys. Sometimes I don't have only one solution for the most simplified version, as you will see by the end of the slides here. Sometimes the most simplified can have different options, and all of them are the same, okay? But different versions, and all of them are most simplified. So I'm not claiming in most of the questions, the answer is yes. Most of the question, you have only one solution. The most simplified is only one. But in some cases, as you will see by the end of this section, sometimes the most simplified can be, there are more than one solution, and all of them are the same level of simplification, as you will see. Anyway, so now the second part. Now, once I decide the groups is this way, so when I grade this part, number one, I'm gonna put some points on. If I give you function, how you make the map using the functions. I'm gonna put some points on that. Number two, I'm gonna put some points on grouping. Have you done grouping correctly or not? Number three, I'm gonna put some points on, once you did grouping, how can you get the term of this group? Okay. So let's start with this one here. As I told you, so what is the term equivalent to this one? As I told you last time, because it is two, so your term should have only two variables. Okay, so it has only two variables. So we need to eliminate one of them, x, y, z. I need to eliminate one of them. Let's see. For example, if you look here, this one, let's look at x. This is in the area of x, or the area of x prime. As I told you last time, this is x, and this is the area of x prime. It's very clear. This group lies in the area of x prime. So I should have x prime. I'm done with x. Let's look at y. Y, this group is not in y, and also it's not in y prime. If you see here, this is y, this is y prime. Have here. So y is eliminated. Y can't be in the term. Okay. Now let's look at z. This is the area of z. So is that in z or the area of z prime? No, it is in z. So it's x prime z. Very simple. Okay. And then this is one group. The second group here, let's work on the, any question for this one? Anyway, let's see the second one. If you don't understand, I repeat a lot in this part. Anyway, so let's look at this second one here. This is in x area, so it should have x. What about y? This is the area of y, and this is the area of y prime. So this one has to be y prime. What about z? I already know, because I have x and y prime. There should be no z, because I should have only two terms. But if you look here, half of it in the area of z, the other half in z prime. So z is not. Once I got these two terms, I can just or them together to get F. So F should equal these two terms. Any questions? Okay, I'm gonna tell you about something very tricky. Please be careful here, okay? Look here, guys. Yeah, look here. This map is created for this specific case when X, Y, Z. When Z is the least significant bit, as you see here. So here, this is the least significant bit, okay, and this is the most significant bit. So X, Y, Z. So in this case, we have this map. Okay? That means if I make here, if I put Z here and Y here and X here, this map is not true. Okay, so because you changed everything. So again, same thing. If I in exams, because maybe I'm not going to use X, Y, Z all the time. I can use A, B, C, for example. So for example, if I use A, B, C, so here X here is going to be A, Y here is going to be C, and this is B and this is C. Okay. Again, what I'm saying here, I'm not saying it's wrong. I'm not saying it's wrong to call this one, to make X is the least significant. I didn't say that. But if you wanna do this way, you have to update, you have to change the map so that this map can fit this one. Okay, you have to update the map just to make it easy. Why you update the map so that every X here should be Z and every Z should be X. But anyway, don't make it difficult for yourself. Okay, all what you have to do is that when I say A, B, C or X, Y, Z, that means this one is the least significant one here. This is the one that should have 0, 1, 0, 1, 0, 1. And this one here is actually the most significant. So this one should have 4 zeros, 4 ones. Is that clear? Any questions? Okay. And again, I don't want to go to, because our main focus is how can we use the maps. Okay. I shouldn't teach how we design the labs, but I give you some simple idea about how we made them this way and why we made a trick last time. You remember the trick? This one 0, 1, and then 3 and 2. It's not 2 and 3, and then 4, 5, and then 7 and 6. Okay. Again, we made it this way so that if you add these 4 terms together, you are going to get Y. Okay. We made it this way so that if you add these 2 terms together, you are going to get whatever. So we made it so that it can work this way. Anyway, let's have more examples here. Yeah. For example, here in this example, I can give you the equation. I can give you the equation this way. That means these are the main terms, the location of ones. So I'm going to put here, I'm going to at 4, 5, 6, at 4, 5, 6, I'm going to put 1, 1, 1. Okay. One way to do it is, as you see here, so I need to cover these 3 ones. I can make this one as one group, and I can make this one group. Okay. This is not the most simplified one. Why? Because I have a better option for this one. This one can, because it has a neighbor here. I can combine it with its neighbor instead of taking it individually. I can combine it with the neighbor, as you see here. That's why this one will take me more simplified one. Okay. Someone can tell me, but wait a second, this one is not the most simplified because we have here 2 terms and we have here 2 terms. They are the same. No. If you go to last lecture, I made a definition. What is the most simplified? The most simplified, number 1, it has minimum number of terms. So in this regard, yes, both of them are the same. However, the second thing here for the most simplified, number of variables in terms should be this number, and this is the case. Here you have 3 variables. Now I was able to reduce it to 2. So if I take this one alone, it's going to be alone, so 3 variables. If I combine it with this one, it's going to be 2 variables. Okay. Anyway, let's look at this problem. I need to keep repeating because you already know that here, as I said before, I can give you this one, min terms or max terms. in exam, I should not give you everything this way, right? Here, I just want to tell you, I can give you the function, this function, this one, or this one, or this one. And in chapter 2, explain. And also, I can give you the truth table. Okay? So now, 4 ways to get it to you. Any one of them, if you have one of them, you can get the other one. That's what I did in chapter 4, right? Sorry, in chapter 2. Anyway, so here, these are the location of zeros. These are the location of ones. Okay. So I just made it this way. So now let's look at what are the best option for you here. For sure that I can take these two together, and then instead of taking this one alone, no, it's going to be better if I take it this way. Any questions? Yeah, sure. For example, let's look at this case here. Let's look at this case. Do we have any better options than that? I can just take these two ones and these ones together, and I'm gonna get equations this way, okay? Because these are neighbors. However, these two are not neighbors, as I told you. Anyway, here, and that's what you need to learn. Sometimes I give you the function this way, and from this function, you have to put x here. Okay. And I made it very easy. By the way, I can do it in 2 different ways. I can know what, for example, this one, I can put one here in 2 different. Let's start with the first one. Look here, guys, very simple. This one, 3 terms. That means it should be only 1 square. 3 terms, 1 square. 1 square, 1 square, 1 square. Is that okay? Sorry, three variables, not terms. Okay. So anyway, so let's look where is the location of this one here. I'm gonna teach I already taught 2 different ways. So let's start with the first way. The first way is, if you look this one, so this square is in the intersection of the area of x prime and the area of y prime and the area of z prime. Okay, let's see what is this intersection. So this is y and this is y prime. Okay, and this is x prime. So now the intersection, I have 2. When I did the intersection for y, I have 2 squares. Okay, if I do the intersection of z prime is here, this one and this one. So if you look at the intersection of 3s, it's going to give you this one. You get what I'm saying? This is one way to do it. The other way to do it is in today's quiz, I'm going to give you the truth table, and then you can get the mean terms. Is that okay? You can do the opposite as well. And that's what this is the mean term. I can know this one is M0 or M1, so I'm going to do now the opposite. This is another way. Okay, whatever you like, it's okay. So how can you do the opposite? I'm going to tell you how. So for every prime, just put 0, 0, 0. So this one will be equivalent to rho 0, 0, 0, which is M0. Okay. Any prime, put 0. Any, if not prime, put 1. That's it. So this one is actually 0, 0, 1. So this one should be M1. Okay. Again, whatever you like, both are okay. 1, 0, 0. So this one should be number what? 1, 2, 3. 1, 2, 4. This is 4, right? So it should be here. Okay. This one here should be 1, 0, 1, which is 5. Should come here. Anyway, now once I made the map this way, okay, what is the best option? The best option is just make one group of these 4, and this should be y prime. Y prime. This is the area of y prime. Okay, because they are 4 ones. I have only one variable. Okay. Even if you try to make mistake, you should not be able to make mistake. Even if you try. For example, if I make a mistake, okay, I'm gonna assume this one has z. I can't do it because you see half of it inside the area of z, and the other half in z prime. So I can represent this one in z. If you look at x, half of it in x, half of it in x prime. So which one I have to take, x or x prime? So even if you try to make a mistake, you should not be able to make it. Right? You got what I'm saying? So anyway, so this is the area of z prime, of y prime. And you already, know, in case of 4 ones, it has to be only one term. Very easy. Anyway, so again, maybe I'm going to go now fast. unless you have any questions. I'm gonna go first in this example. I want you to understand these examples. I have 14 examples, okay? Just to learn from them. So for example here, yeah, for example, the best way to do it, I can take these two together. I can make only one term this way. Here in this case, the best case for these ones, I can take them this way. What about the last one here? Because I need to cover all ones. This one I can take it alone, which is a bad idea because I can take it with the neighbor. Overlap is okay. Any questions? Okay. Number 10. Again, look here, number 10 is a little bit tricky. Look here. If I give you this one, how can you locate the ones here? How can you locate the ones here? Okay. Look here. Because look at this one first. Because this one has two variables. So how many squares it should be? It should be 2 squares. So this one here, when I represent it here, it has to be 2 squares. I have to put once in 2 squares. Which 2 squares? Again, this one's the intersection between A prime and C. Okay, so this is A, and this is A prime. So this is A prime, and this is C. So intersection should give you these 2. So because of this term, I'm gonna put ones here in these 2. Is that okay? Okay. Let's look at the second term here. Okay. So these 2, I put here 1 from the first term. Let's use a different color. Yeah. Now I'm gonna work on this term. A prime B. So B is here, so it has to be here, and A prime has to be here. Okay. So that means I'm gonna put 1 here again, which is okay. So this one, because this is not the most simplified one, so you can put here 1 and you put another 1, and you have to continue this one. This one, it should be 2 ones, B and C. This is B and C is here, so it has to be. I put 1 here and put 1 here. Anyway, again, keep in mind, if you have three variables, so it should be only 1 square. If you have 2 variables, it should be 2 squares. Okay, only 1 variable should be 4 squares. Okay, anyway, so after that, what is the best option I have here? For sure, I have very good group here, group of 4. That's a very good one. And then here I can take these 2 together, 2 ones, these 2. By the way, sometimes I don't put zeros here. Okay, sometimes we just put the location of ones because I'm gonna work on ones, so there is no need to put zero. But you know, if this is squares at once, this other square should have zeros. But sometimes, so it's okay. Sometimes we don't put here zeros, but because I'm gonna work only in ones, that's okay. Or you can put zeros. It's not gonna make any difference. Again, it's not allowed to include 1 0, okay, or any zeros in the groups. These have to be groups of ones, okay? Because that's what we did in chapter 2. Chapter 2, to get the equation of the function, we work on the ones, not 0. Okay? Anyway, number 11, I can take these 2 together, and also this. Don't forget these 2 are neighbors. It can be only 1 term. Number 12. So here I can take these 4 together, and for this one I can take it alone, which is a bad idea, but I can take it with this one here. Okay. Number 13. So now, okay, there may be several solutions here. I have no idea, but no, I think no. Anyway, I don't think. But anyway, so for example here, yeah. So for example, this one I can make this group is it, or I have this group as well, because this one is a neighbor to this one. These 2 neighbors. Is that okay? So I can take this as 1 group. I can take this one with this one as 1 group. Okay. And then, yeah. So actually here I can do it in 2 different ways, and both of them are correct. Okay, but let me finish this one first, and then I'm going to tell you what is the other one. Okay? And then I can make a group this way, and then I can make a group this way. Okay? But in this case, I'm going to have a redundant group, which is this one. So this one is redundant. Why? Because this one's already covered in other groups. All of them covered. You get what I'm saying? So if I add another group here, it's not gonna. I add another term. It's not gonna be the most simplified. The other way, as I told you, okay, is I can, this one, instead of taking this one with this group, as I did here, I can just take this one with this one and cancel the green group. So now you are going to get second solution, okay, and the two solutions are correct. Let's do it. You understand what I'm saying? So what I'm saying is that what I did here, guys, is this one is a group. Okay, we agree on this one. So this one is done. This one here is one group. Okay, this one is okay. It's done. And then now I have two options for this one. Either I take it with this one as a group, and that's what I did here, and this is the one I got here. The second option is, well, again, these two terms are okay, are done, but I'm talking about this one here. I can take this one with this one here, okay? And in this case, instead of having this term, I'm gonna have another term. This term is actually x prime, z prime. Is that right? Z prime and x prime, okay? So now I have two solutions. The two solutions are most simplified. Either this term x prime y prime or x prime z prime. You get what I'm saying? This is a very good example, as I told you. In most questions, usually you have only one solution, most simplified, but in some cases you may have more than one. Okay? I think also here I'm addressing the same issue here. I want to show you I can have two possible simplified solutions, as you see here. For example, I can take this one together, these two together, and I think take these two together. Okay. Or I can take these two, take these two, take these two. Both of them are most simplified. Yeah, sure. Seven is 0, yes. Oh, you are right. I'm really sorry for that. Yes. I'm gonna correct this one. Yeah. So this, assuming there is no 7, thanks. This is a typo. So here's a question. The problem is not in the way I did grouping. The problem here, we have 0, 1, 2, 5, 6. So I have to put 1 0. I put 1 here. 1 here. 0, 1, 2. What is 2? 2 0. Okay. And then 5, 6, 5, 6. But I forgot to put 1 here. Okay. So to correct this slide, either or the easy way, I'm gonna just cancel this one. There is no one here. Okay. But if you put 1 here, okay, so now I have to take it into account. So if you put 1, let's solve it. What if you have 1 here? Okay. So again, so I need to add one more term. I need to add one more term. I can take these two together and add one term, or you can take these two together and add one more term. You got what I'm saying? This is nothing else I can do. This is not 1 here. I can add it to this group. Okay, or I add this group. This is the best I can do. Okay. Someone can tell me, oh no, you can take these 3 together. These 3 together. No, this is not a group. This 3 is not one group. Yes. Which ones? Tell me which main terms. M0, M1, M0 and M2. Okay. M1, M5. Okay. 6 and 7. So yeah, how many terms? 1, 2, 3, 3 terms, right? Yeah, this would be much better than what I did. Yeah, this one is more simplified. You got what I'm saying? So if you have here 1, yeah, this solution would be more simplified than what I expected. Okay. So now you can take these two together. Okay. This one, and then this one you can take it with this one. By this way, I can cover all ones using 3 groups instead of 4. Anyway, yeah, you need to be careful when you do it. Okay, I just did it quickly. So anyway, we make. But anyway, thanks for this typo. So for now, we can just cancel this 7. Okay. Any questions? Okay. You have question? 2 minutes. We're gonna have 15 minutes. It's very easy. Man, don't think about the quiz. Think about what I'm teaching here. I didn't give you a quiz in the beginning because I didn't want to exhaust your energy in the quiz, and then after that you may not understand the lecture. Anyway, so let's come to what I'm gonna revisit. I wanna revisit what I did in chapter 2 about don't care. Okay, don't care. You remember in chapter 2, I told you sometimes the truth table may have 0 and 1 and may have X or D, also X or D. Some cases we call it don't care. Okay, and so here, so I'm not gonna come here. I'm gonna just come here because that's what you need in the coming lab. It's just very simple thing. You will understand what I'm saying here before I go for 4 cells. Yeah. Yeah. So for don't care, this is usually for any truth table, I should have 0. So that means, what is the meaning of truth table? Okay. If this is the input, the output of the circuit has to be 0. If this is the input, the output of the circuit has to be 0. If this is the input, I want the output to be 1, and so on. Is that okay? That's the meaning of truth table. And be careful now. Now, I'm just doing it randomly, 1 0 1 0 1 0. Starting from the coming lab and starting from chapter 4, I'm gonna put these ones and zeros to do a certain functionality. I want to do add, I want to do subtraction, so that this one has to be 1 in order to get correct result. So it's not gonna be something random. Here I'm just teaching if you have the truth table, but in the future, if you have the truth table, how can you get a simplified function? That's what I'm teaching here. But in the future, I'm going to create the truth table in a certain way to make a circuit that's doing something. Okay, addition, whatever, multiplexing, decoder, things. You will understand better what I'm saying. That is why what I'm teaching now, I'm going to use in all chapters until the end of the semester. K-maps and everything, I'm going to use them because I'm going to create, and that's what we're going to do by doing the coming lab. So it's a coming lab. I give you some description to something I want to do, and then you need to create the truth table. And then after you create the truth table, you are going to use the K-maps to simplify it, and that's okay. Anyway, regardless of what I'm explaining now. For example, if the input here is BCD, as I told you before, BCD means number from 0 to 9, but they are in binary. So they have to be, so these are all possible cases for the input. In this case, although the circuit allows to input 10 or 11 or 12 or 13 or 14 or 15, because I have 4 inputs. So 4 inputs, so you can input this number. You can input 0, 1, 0, 1, 1, 1, 0, 1. Okay. So, and these numbers should not be correct, because if you want to use the circuit correctly, the circuit has to have number. It's the input. Is that okay? But because it's 4 inputs, you can input any one of this one. So let me ask you a question. If you design this circuit, if the input is any one of these, does it matter for you? That's why we have the term don't care. Does it matter for you if the output is 0 or 1? I don't care if it's 0 or 1. You got what I'm saying? So for example, here I have a circuit. This circuit, I want to recognize the numbers 2, 3, and 6. So if the input number is 2 or 3 or 6, I'm going to give you 1 here. Otherwise, I'm going to give you 0. Okay? And that's what I did. What I did here, I want to design a logic circuit so that to recognize 2, 3, and 6. That's why at 2, I put here 1. At 3, I put here 1. At 6, I put here 1. Okay? So this one should give me 1 in these cases. If the input is 2 or 3 or 6, it should give me 1. Is that okay? What if you put another input? Because this is a BCD, the input has to be between 0 to 9. If you want to use it correctly. What if I put something else like 10 or 11 or 12? I don't care, because this input should not happen. Okay, so I don't care. So that's why here I'm saying I don't care if the circuit is gonna, because this is a logic circuit. This is electronics. Even if you put something like here, you have to get a voltage. This voltage can be 0 or 1. Okay, so you will get something. Even if as a user to the circuit, this input should not happen. That's true. But if you put this input, you will get something. But I don't care. If it's 0 or 1, I don't care, because you put a wrong input. So I don't care about what you are going to get. But now, as I explained in chapter 2, now these two together are very valuable for me in simplification, because if it is good for me for simplification to consider this one once, to make groups bigger, I'm gonna make them once. If good for me to, if it's not good for me, okay, I'm not gonna consider them once. You know what I'm saying? But so that's what I'm gonna explain right now. I have a very small example here. Here. So in this example, yeah, in this example here, I'm showing you, as you see here, we have here 0, 0, 0, and we have x, x. Sometimes in maybe in some books or in Xi books, they use the D for don't care. It doesn't matter whatever you use. And the way, and I think that's what I did in the lab. So what, yeah, usually we express it this way. And that's what I did in the coming lab. So I'm gonna tell you here, this is what usually we do. These are the main terms and these are the don't care ones. So here that means at 0, 2, 5, they are don't care. Okay. Anyway, that's what, this is the way we write it. But anyway, let's come to my point here. My point here is, look here, guys. I'm not going to change what I said. In order to get the most simplified ones, you have to cover all ones. I don't need to cover all x. I don't care about this x. You know what I'm saying? You don't need to cover all x. Okay? But if it's good for you to take x, just take it. If to make bigger groups, and this is exactly what I did. So what? Let's look if I don't here. So here, if I don't take x into consideration, look, consideration as you see here. Okay. So I'm gonna take this one and this one, and then I'm gonna take this one alone. Okay. So here I didn't use any don't care. Okay. In other words, I'm gonna consider this one 0. I'm gonna consider this one 0, or the circuit will make 0 here and make 0 here. And in this case, I got this function, but this is not the most simplified one. Okay. I would, if you use the don't care, if you can consider this don't care as once, if you consider this don't care as once, I can make a much more simplified function. And in this case, here in this one, the circuit is gonna give 1, because I don't care if you 1 or 0. By the way, if you have x here, you are not, because this example may confuse you a little bit, okay? Because I covered the 2x I have, okay? But that doesn't mean I have to cover x, okay? All x. For example, I may have x here, and then I'm not gonna make it in a group. Okay? So the conclusion, guys, is number 1, you should understand what is the meaning when I put 0 here, when I put 1, and what I put x. What is the meaning of that? The meaning, if this is the input M0, so I want to get 0. If the input is M1, I want to get 1 to get a correct functionality for the function. When the input here is 3, I don't care. If it is 0 or 1, I don't care. Is that okay? So now I have the choice. I have the choice to make this x once or zeros. Maybe I have another x here and I can consider it 0. And this one I'm going to consider it 1, and this one I'm going to consider it 1. So you don't need to cover all x in groups. However, okay. However, if you if it can, so what I can do here, I can just take this one as one group. If I can take this 4 as one group, okay. So, and also, as you see here, and also I can take this one with this one. So simply what I did here, I just consider it as a 1. In this case, I'm going to get a more simplified function. And in this case, this circuit is going to output 1 here and output 1 here. And I don't care if output 1 or 0, I don't care. You know what I'm saying? But if you do this way, I'm going to output 0 and 0, but it's not the most simplified. You know what I'm saying? Yeah, you have a question here, or I have already answered? Oh, right. Here. Which, yeah, this one. Yeah, because this one is in Z, yeah, and X prime, because this is X. It's in the area of X prime. So I'm going to correct this one. Thanks. X prime Z. Yeah. Any questions? Okay. So now we are ready to move to the next one, which is 4 variables. If you have 4 variables, nothing is new. I'm gonna do exactly everything again, but now it's gonna be more difficult. I don't want to use the more difficult. You have to be more careful this time. Why? Because now the map is bigger, so you have to look for groups. You get what I'm saying? That is why if it is more than 4, variable, it's gonna be difficult for us. That's why in this course, most of courses we limit it to only 4 variables. If you have more than 4 variables, there are computer programs can do it. You get what I'm saying? So now I'm similar to what I did before. I'm gonna show you how the map looks like. Who are the neighbors? How can you make groups? Same thing as before. Okay? So let's look how here, if you have 4 variable, something like this one. So in this 4 variable, I'm gonna call it W, X, Y, Z. Is that okay? So now, if I do this way, Z is the least significant, W is the most significant. Okay? So now I have 4 variables, W, X, Y, Z. Okay? In this case, this is how the map, as I said before, if you have 4 variables, so the map should be 2 to the power of 4 should have 16 squares. Okay, that's similar to what I did before. In case of 3, 2 to the power 3, which is 8 squares. Okay, because here we have 8, we have 16 cases. For every row, for every case, we have 1 square for each one. Is that okay? Similar to what I did before. But look how we're gonna do it. Look here, guys. We have M0 here, M1, M3 and 2, similar to what we did. So you need to switch the last column, you need to switch it. Similar to what I did in 3, okay? And then after that, 4, 5, 6, and 7. So the last 2 are switched. And now, and this is different from what I did in 3, also I'm gonna switch the last rows. So here, again, 0, 1, 2, 3, 4, 5, 6, 7. Until now, that's exactly like 3. What I'm gonna do right now is also I'm gonna switch this one. So after 6, after 7, gonna be 8, 9, 10, 11. And then, okay, after 11, 12, 13, 14, 15. Okay, again, we do this, we switch this way, okay, again, in order to make neighbors so that they can become neighbors and you can group them together. Any question? Again, so this is similar. So the order here, I'm gonna switch these 2. Okay, same thing here also. I'm gonna switch them. But anyway, you need to know how the min terms are gonna be here. Okay. So, and also regarding areas, the same thing like what I took before. It's the same thing regarding areas. These are how the areas are. So here, W is here. W is here. W prime is here. So this is W prime and this is W. This is the area of W prime and this is the area of W. Is that okay? Same thing. This is the area of Y. Okay. And this is the area of Y prime. This one here is Y prime. Okay. Similar to what I explained to you before. Okay. Also, this is X. And this is X prime. These 2 are X prime. So this is X, and this is X prime. That's okay. Z, so these are Z, and these are Z prime. Okay. And similar to what I did before, can you get the min terms? So these are the min terms. So if you look at this min term here, okay. First, this is M0, so I can get it from here, okay. And that's what will be. And suppose today would be something like that, okay. So in order to be this min term, because it is 0, it should be prime. That's what right. Similar to what I did in 3, okay. Also, this one means this square is in the area is the intersection of W prime, X prime, y prime, z prime in this intersection. Let's see. So this is w prime is this way. X prime is this way and this way. So for sure, until now, the intersection is here. That y prime is here. So these two, until now it's 2. Okay. If you look at z prime will be this one. So this one will be in the intersection of these 3 areas. Okay. Same thing for any other term. Same thing. For example, if you look at this one here, w, x, y, z. This is here, number 15 here. Okay. So this one should be in the area of w. So this one in the area of w, in the area, sorry, in area of x, area of w, the same area, and the area of z, and also the area of y. This is the intersection of these areas. Is that okay? So again, same thing as I explained before. Same thing. Now, let's look now about neighbors. Which square I can group? Same thing as I explained before, but there may be some changes here. That's what I want to teach. But everything else will be the same. Just here, just bigger. The map is bigger now, but everything is the same. So the first thing I want to teach here, as well, similar to what I did before, the same way. If I give you a truth table, how can you put ones? Similar to what I did before. If I give you the truth table, that's very trivial. For example, if you see here, this is M1. So in M1, I have to put 1. In M6, I have to put 1, and so on. So I have to see where are the ones here, where are the location, which mean terms are ones, and then I'm gonna put in the location. Because this is main term 0, main term 1, main term 2, 3, and so on. Okay? So this is exactly the same thing I did before in 3 variables. Okay. I can give you the function this way. As you see here, I can give it this way. And also the same thing. So here it has to be at 2. It has to be at 3. It has to be at 6. It has to be at 10, and so on. And also at 15. Okay. This one. Okay. Now let's talk about neighbors, adjacent. In case of 3 variables, every square has 3 neighbors. In case of 4 variables, every square has 4 neighbors. In case of 2 variables, every square has two neighbors. Okay. So now let's look at for each one, where are the 4 neighbors? Okay. So for example, if you look at the neighbor, and if you look at the neighbor of M2, for sure we have a vertical neighbor and horizontal neighbor, vertical and horizontal neighbor this way. Also, this one is a neighbor to this one, similar to 3 variables. What is new now? This one also is a neighbor to this one. So you can imagine, it's like, if this is the map, this is the map. So this side is like ruled this way. That's why this and this here are neighbors. Also, it is ruled this way as well. Maybe it's difficult to imagine. That's why this one is neighbor to this one, and this one is neighbor to this one. Okay? So you think about it, it's like it's ruled this way, so that the ones here are neighbor. Also, it is ruled this way. Again, if you don't believe me, I made a definition what neighbor means. Neighbor means they have the same variable except 1. They change only in 1. So you can simply go back, and based on what I have here, you can see I told you this one is a neighbor to this one. Okay, this one is a neighbor to this one. If you look here, you can find there is only one change between them, so they are neighbors, right? Anyway, so let's see more cases to understand what neighbors mean. So this one here, who are the neighbors of this one? For sure, we have horizontal and vertical neighbors. Also, we have neighbor here. Okay, remember every square has 4 neighbors. What about this one? Same thing. This one has vertical, okay, and also horizontal, and then a neighbor here. What about this one here? This one has this neighbor and this neighbor, and also this neighbor, and also this neighbor here this way. Okay. I think let's at least, yeah. So for example, this one here, it's the same thing. This neighbor, so these are neighbor here. So what I mean here, guys, I'm not saying you can make a group this way. I'm not talking about groups now. Don't be confused. I'm saying if this one and one I can take as, and also this one I can take it. I'm talking about these are two neighbors because I'm gonna talk about groups later. Okay, so I can make this if both of them are ones, or I can take this one here, or I can take this one here, or I can make a group this one of two ones. Okay. Same thing here for this one here. It has two vertical and two horizontal neighbors. Same thing here. Okay. Any questions? So I'm gonna continue. Again, the good thing, nothing is new. So similar, if you understand three variable, it's exactly the same thing, but on the bigger map. It's a little bit more, you need to be more careful because you have a big here you are gonna have more options. So you need to think which groups I have to put them together because now the map is bigger. You know what I'm saying? Anyway, I think that's enough. We can start the quiz now. I need 3 or 4 volunteers to help me to distribute these ones. Distribute the quiz.